All right, so we've reached the point where we're going to talk about the structure of an atom. And I said before, I mentioned one of these subatomic particles, protons, I mentioned before. But there are three of them that we talk about. If you take chemistry or physics, you'll probably get a much more detailed discussion of atoms. But for our purposes, we're just going to talk about the three major subatomic particles that make up every atom. Every atom is composed of three different types of subatomic particles. And the one we mentioned before, the ones that I have a P with a plus on them here, notice it's in the nucleus. In the nucleus, we have protons. And these, we're going to say this, and then I'll explain why I'm pointing out big versus tiny. But protons are big, and they have that plus. That means a positive charge. We have two different kinds of charges, positives and negatives, and positives and negatives attract, right? So the protons are big, they're found in the nucleus, and they are positively charged. Also, what was the other thing we said? We said the identity of an element is determined by the number of protons. So if you have three, like I'm showing here, it's something called lithium. Don't worry about that. It's just the example that I used. So because anytime you see only three protons, it's going to be lithium. If there was only one, it would be hydrogen, two helium, so on. But don't get hung up on that. So the first of the three subatomic particles are protons. Now, inside the nucleus also, we have another big particle, and that's called a neutron. And it has no charge, so it's just there. It's part of the structure of the nucleus. Now, around the outside of the nucleus, we have some teeny tiny particles. They are actually 1/2000th the mass of a proton or a neutron. So they're tiny. They're tiny little particles, and they have a negative charge, and they carry energy. So energy, the energy, they carry energy, so they're in motion. And they are found in what we call orbits around the nucleus. And depending on how much energy they have, they can be close or far away. So if you think about it, positives and negatives attract, and you have energy. If you have just a little bit of energy, you're going to be moving close to the nucleus because there's this attraction to those protons, and you've got energy, so you're orbiting around. Now, if you have more energy, you're going to be orbiting further away. And so what happens with electrons is they have a certain amount of energy in them, and that determines at what distance they are from the nucleus. Now, why do we care about that? Well, it ends up that electrons can be lost by one atom given to another one, and received by that one, or they can be shared by other atoms. Now, why would they do that? Well, it ends up that what we call these areas that are filled with electrons, where the electrons are orbiting, we call them orbits or electron shells. And in order to gain stability, another way of saying that is we say, the atom wants to have all of their electron shells, they want them to be filled. And so in the case of this atom, this inner shell is filled, but it has only one electron in its next higher energy state, and that's because you have the same number of electrons as protons. So we have 3 protons, 3 electrons, and so that in order to fill that next shell, it needs 7. So what happens is reactions between elements are all about trying to figure out either giving away an electron or sharing pairs of electrons with somebody else, to form what we call compounds and molecules. And so atoms come together and help each other, basically. They work to achieve stability, this desire to have filled electron shells. And as a result of that, we produce compounds and molecules. And these, what are these? What are compounds and molecules? They are combinations of two or more atoms. And some common examples, everyone knows these. Carbon dioxide. You notice I have a C and an O with a 2. What does that mean? It means we have one carbon, 2 oxygens, and they're combined together. And the way they're combined together, they are making filling the electron shells, so that the elements are stable. Basically, is what we're saying. Water is another example. 2 hydrogens and 1 oxygen. And oxygen gas is the third example I have up there. And it's just 2 oxygen atoms together, combined, sharing pairs of electrons so that they're stable. All right. So that's the structure of atoms and why we have reactions and these compounds and molecules. It's because of the electrons and trying to gain what we would refer to as stability.